Hello, students. Got a couple questions coming in from 13.3. Now, this is question 12, and the student asked for parts A and B. So let's take a look here. So we've got two triangles, right triangles. Let me get a little bit of white space in here. Now, both of these triangles are what we would call special triangles. And all that means is that if we remember their ratios, we don't have to do a lot. If you don't remember the ratios, you have a little bit more to do. Let's see here. Honestly, the one on the right is probably easiest, and that's because we know the side at the bottom is S, and because it is a 45, 45, 90 triangle, the other side must also be S, and it asks us to find the area. The area, I don't need the hypotenuse. If you did need the hypotenuse, that would be square root of 2 times S, because that's the ratios, but not needed. So here, all we need is the area formula, and area is 1/2. 1/2 times base times height. And in this case, the base is S, the height is S. So this would be S squared over 2. That would be your area there. So again, that's just looking at what we know about that particular triangle. Okay. Let's take a look at the next one. Next one is equilateral. So pay attention to that. That also means that it falls into one of those nice ratios. It means we have sides of S, S, and S, but then if you look at the triangle that's actually being made, and when I say that, what I mean is the right triangle that's being made. So picture kind of this line coming down the middle right here, and that's kind of what I'm referring to, okay? So it's, of course, I'm still using white. Let's see here, this line right here. Excuse me. So we have a right triangle. The one length is S, the longest side, which means the absolute shortest side is S over 2, and that's because of the ratios. So this is a 30, 60, 90 triangle, and you can also see in the picture here that the perpendicular bisector, or the perpendicular line coming from one point to the other, will create two congruent triangles. And so you could use that as well if you wanted to. But we have S over 2 here. You can use the Pythagorean theorem to find the height, or you can use the ratios. If you use the ratios, you're going to end up with, let me try to draw this one instead. You're going to end up with the square root of 3 over 2 times S. And I know it looks kind of sketchy right now, but that's because my other little tablet piece is upstairs. I want to make this video and take care of it. So this would be your height. This right here is the height of that triangle right there. And just remember, the ratios are always going to be the same. It's going to be 1 to root 3 to 2. So if you divide everything by 2, then the long side over here would be 1. The next side would be root 3 over 2, and the bottom side would just be 1/2. Now, in the general picture, the entire base of this triangle is S. So take the same formula, 1/2 base times height, take the base, which you know is S, take the height, which you know is this thing right here, multiply those, and then don't forget to multiply by 1/2. And there you go. Let's take a look and see if there's anything else this student had in mind. I think there was one other piece. Let's see here. MC13. Looks like all parts. ABCD is a right triangle. With right angle, it's C. Okay. CD is the attitude. Attitude. It's the altitude to the hypotenuse. So that means that it is forming a 90-degree angle right here, which divides the triangle into two right angles marked 1 and 2. Okay. Now they want to show that area 1 to area of triangle ABC is B to C squared. Ah, so what they're going to use here is the fact that when you have linear measures, like the side lengths, if you take this small triangle right here, the hypotenuse is B. If you take the bigger triangle, oops, if you take the bigger triangle right here, which is similar because they share this angle down here and they also share a 90-degree angle, but its hypotenuse is C. Therefore, the ratio of sides between two similar triangles, the ratio of sides is B over C. That's the ratio of sides. Now we're talking about the ratio of areas. And the ratio of areas, what we have to do is we have to square it. And so B over C, when you square it, gets you this. I'll let you do a similar one for triangle 2 and triangle ABC. It is pretty similar to form the second one. And then all you do is take these two right here and add them together, because that will get you this component right here. And if you simplify just a little bit, get a common denominator, stuff like that, you'll be able to get there. And lastly, the last piece is more of just look at the picture. You've got triangle 1 here, triangle 2 here. When you put those two together, what shape do they make in terms of the areas? And hopefully you can see that area 1 plus area 2 gives you the area of triangle ABC. And if that's true, then the area of ABC has to equal this area of ABC, right? With this ratio to C squared, it has to actually equal the C squared. So that is what they're talking about there. And that's why basically, let me see if I can phrase that a different way. Maybe this will help too. When you look at this piece on top, area 1 plus area 2, and you look at the picture down below, you'll have to see that that is exactly the same quantity as the area of triangle ABC. So those are equal. So this ratio, what's on top, has to equal what's on the bottom. So you could say this ratio equals 1, and then multiply, get rid of your denominators, and you'll be able to show that the Pythagorean theorem is indeed true. So that wraps it up for this one. Couple MCs, couple homework questions. Thank you so much for the question, and hopefully this helped get you back on the right track. All right, off you go.